Hi. Good afternoon. Thanks for joining our talk around digital sovereignty. My name is Louis. I lead the EC2 core product management team, as well as AWS Digital Sovereignty. And I have David Woodhouse with me. He's a principal engineer on AWS working on digital sovereignty as well. So today we're going to discuss how AWS can help customers meet the growing and rapidly evolving sovereignty landscape that we see both in Europe and increasingly globally. So I'm going to talk through a couple of things. First of all, discuss what digital sovereignty, really means. We're going to look at what are some of the workarounds that customers are exploring in light of the increasing sovereign requirements that they face. What are some of the trade-offs and hard decisions that customers have to make? We're going to talk about how AWS approaches digital sovereignty. The fact that our architecture, our global footprint and capabilities have been designed since day one to be sovereign by design. A big part of sovereignty is earning trust of our customers and regulators. So what are we doing there from a transparency and assurance standpoint, as well as leverage our hundreds of thousands of partners around the world to better help customers navigate through these uncertain times. So what is digital sovereignty? We live in a world where right now there's a lot of uncertainty, there's a lot of political instability, which has prompted a lot of governments, nations to think about, hey, how do they retain control of their critical infrastructure, their data workloads, their digital economy. And that's the right thing to do for them, right? But we also see that there is no single definition of any of that today. A lot of digital sovereignty expands beyond security, privacy, and cybersecurity regulations to things like control and ownership, but it is highly fragmented across countries around the world and even within a geographical region like Europe, for example. We see in Germany, for example, the government has come up with cybersecurity standard like C5, which AWS achieves, that sort of dictates requirements for public sector workloads running in the cloud. In France, there is Secnum Cloud, which come with its own unique requirements around ownership and operational management. But also across other regions, like, for example, Asia Pacific, many countries such as Singapore has taken a more pragmatic approach to digital sovereignty, and they are actually leveraging a lot of public cloud on AWS to meet their digital sovereignty requirements. So like I said, it is very fragmented today, and the challenge is there's really no uniform guidance around what kind of workload, what industries or sectors really need to adhere to these requirements. But the good news is, in Europe, for example, there are attempts right now, like with EUCS, for example, to try to harmonize that a little bit, right? To bring some sanity and some consistency across the member states around what it means to be digitally sovereign. Those efforts are still early on, and it may take many years to materialize, but we're hopeful. And our customers in Europe and increasingly globally tell us, are coming to us and asking us for help to really navigate around these uncertainties. In fact, I think IDC has a study survey that says 80% of organizations in Europe consider digital sovereignty to be sort of like the highest priority right now for them. And they tell us that they need the confidence that their workloads are protected and that their cloud service providers, in this case like AWS, for example, can adhere to those local regulations. At the same time, most of the customers are also very concerned. They are concerned that meeting these sovereign requirements and compliance has negative effects, right? They're concerned that it may bring additional cost, and which makes it increasingly challenging to operate at a global scale. So across the board, we sort of can distill a number of key themes that customers and regulators have been asking for. First of all is data residency controls. So this means that customers really want control over their data. They want to be able to control where their data resides, and they want to be able to control and restrict where the data gets transferred to. The second, and we're going to talk a little bit more about data residency and the capabilities that AWS provides to our customers to help them meet those requirements. The second point is operator access. And in this case, customer and regulator want to make sure that neither AWS nor any foreign government can access their data. And we're actually quite uniquely positioned here, and David is also going to talk a little bit more about this later on, in how we've architected our AWS services, our global infrastructure, to be able to create a really isolated environment for customer workloads such that no operator can access customer data today. A big piece of sovereignty is about resiliency and survivability, right? The recent geopolitical problems, sabotages around European energy pipelines, have raised a lot of these concerns. And regulators want to make sure, and government want to make sure, that their data workloads, their critical IT infrastructure are protected, right? And can sustain through any kind of disruption, whether it is foreign influence or natural disasters and so on. And the last piece is independence. In some cases, we see sovereignty driven by the need to foster the local economy, to be able to drive infrastructure, skill development, right, as well as drive competitiveness at the global scale. Again, I wanted to caveat that this is a generalization, and the reality is that if you look across various sectors and countries, you'll see that it varies to a certain degree. And in Europe in particular, it's still nascent and it's still evolving. And that's where AWS, along with our partners, we can help customers navigate through that. So, customers, we've been hearing a lot about how customers think about navigating around digital sovereignty and sort of the workarounds that they're contemplating in light of these requirements. The first, obviously, is on-premise, and that means that customers are starting to think maybe they should slow down the cloud adoption, maybe they should just keep most of their stuff on-premise, right, and not move to the cloud. There's a belief that staying on-premise brings better security or resiliency and control, right? At the same time, though, the downside is that customers are missing out on the pace of innovation of AWS, the scale, the price and flexibility, and the capabilities that AWS provide. Some customers are taking a little bit more of a pragmatic approach. They will, split their workloads on-prem and also on the public cloud, and that brings additional complexity as well in terms of managing their workloads across multiple environments. With certain regulations, like in Europe, for example, a number of hyperscaler cloud service providers have jumped in and announced that, hey, they're going to build a dedicated sovereign infrastructure in some of those countries. Those are, to our knowledge, still very early in the days. They're unproven, and they come with their own challenges, right, around ownership of the venture, around ownership of the management of a cloud service at the scale that AWS operate with. And those are some of the challenges that we've been, continually talking to regulators about as well.
Yeah, so on the sovereign cloud, you have to think about, just how far do we go with this? Now, to go back to sort of the definition of sovereignty, what does it mean? What are we trying to achieve here? We spent a lot of time talking to customers, to partners, to regulators in various countries around the world, trying to build up that taxonomy of the requirements and understanding exactly what it is that we need to provide to meet these. And it makes a lot of sense that a country wants to know that critical workloads for the smooth operation of their country, the payment processing, the telco, the transport workloads, those cannot be disrupted by any foreign entity, right? And that's a reasonable requirement on the face of it. But what does it actually take to achieve this? Well, you start by having to build your own CPUs within your country, right? Because you can't be accepting a microcode update from a CPU vendor that's outside the country. And it goes to the firmware on the motherboards and the BMC, and I think we all know the kind of things that a BMC within an enterprise machine could potentially do. And then the software that's running the hypervisor from the OS vendor. All that software has to be reviewed in country, but some of that's not possible. If security flaws are released to a software vendor under embargo from the CPU vendor, the Linux community, etc., that comes with a requirement that it cannot be disclosed. You're allowed to ship the fixes, but you're not allowed to disclose the actual flaw until the embargo is lifted. So a software vendor is not at liberty to then disclose that and allow pre-review of the updated source code to the French government, the German government, the Israeli government, the Saudi government. That can't happen. So one option for a truly sovereign cloud is to build all the hardware and to write every single line of microcode and firmware and software all the way up the stack within that country. But that's hard because even countries such as China, India, the US do not have the talent pool to build a full stack from the ground up. It's just not possible. So if you look at AWS, for example, the Nitro hypervisor is predominantly written in Germany, big team in Dresden and Berlin, the EC2 control plane, largely in Cape Town, etc. We say it takes a village to raise a child. It actually takes a globe to build a full hyperscale cloud. So the option of building a completely sovereign cloud within one country, well, that's hard. So we have to look at what is pragmatic, what can we actually achieve, realistically speaking. And so there are three pillars to that. A different way of looking at the taxonomy is data. We ensure that we cannot access customers' data. It goes from the traditional model of trust, and we understand and we respect the amount of trust that customers put in us when they bring their workloads to AWS. Yeah. But it moves from that, trust us, we won't do that, to demonstrating that we can't do that. Now, to a large extent, that's been part of our operational security model for a very long time anyway. Purely pragmatically for matters of scale, we don't want operators to have to actually interact with any one of these, how many machines are there across 30 regions and how many availability? The numbers get silly. If you think about operator access to any machine, we just can't work like that. So one of the things you'll see from us as we move forward is demonstrating. It's one thing for us to have made it true, and we're going to talk a little bit about how we have done so. The other part of that is the assurance that we're going to get to. We're going to be a little bit more open about how we have designed things so that we can demonstrate that we cannot access customer data. And another part of that is the true regionalization, so that a given region is fully independent, does not depend on anything from the outside. So if the cables are cut, then it will continue to operate completely autonomously.
Yep. Thanks, David. And David, you're right? And customers actually tell us that they don't want any of that, right? Like they are forced to have to take on this additional compliance and meet these regulatory requirements around sovereignty. And they come to us and they say, hey, AWS, we don't want to give up on the innovations that you guys provide, right? All the new features and capabilities that AWS release every year. They wanted to continue to benefit, from the price, the flexibility, scalability, resiliency, being able to infinitely scale up and down their workloads, as well as the security benefits in the cloud. But as they contemplate and evaluate workarounds to meet some of the requirements, they go into hybrid, sovereign, on-premise. And these kind of workarounds are trading off against a lot of the benefits that the clouds provide today. And so they are facing incredible amount of complexity, and we firmly believe that customers shouldn't have to make that kind of a trade-off decision, right? Like customers want to get the sovereignty, but without compromising on the full fidelity of AWS. So AWS Cloud is sovereign by design. It's part of our DNA, and it's been something that we've been doing since day one. All of our regions are isolated. Our services are regionalized to be able to operate independently, and we're going to dive deeper into some of our technical architectures on how we make that happen. And our approach to digital sovereignty really is to pledge that we'll continue down this road and commit to help our customer navigate around these uncertain times, continue to develop new feature and capabilities that helps customers meet the growing number of requirements that they face from a sovereignty standpoint. So let's take a look at how AWS can help customers, along the lines of data residency control, operator access, encryption, resiliency, but also earning the customer's trust through transparency, assurance, and leveraging our growing partners around the world. So to recap, data residency, it's at the heart of sovereignty, and it really is about giving customer the full control over what they can do with their data, where they want to put it, the restrictions that they want to place on it in terms of transferring in and out of a particular geographic jurisdiction. And we think that AWS is very well positioned to help customers there. We have the largest global footprint that gives customers this flexibility. And customers can actually use AWS services with the confidence that their data is not going to be moved outside the region that they didn't select. So we have like 30 launch regions today and growing, more than 96 availability zones around the world, more than 410 edge locations, 21 and growing local zones. We have outposts. So we have all this spectrum of services that allows customers to put their data in the countries that requires data residency. And customers have full control over the data. So they can determine where the data is stored, how it is stored, who can access the data. They can choose to move their data from one region to another. They can choose to completely lock it down. So for example, a customer in Europe will be able to select just the AWS services that only processes customer data in the EU. And one of those services that is really cornerstone to the ability for customers to do that is AWS Control Tower. How many have heard of Control Tower? Great. There are a few. Great. So Control Tower really simplifies and really orchestrates a lot of AWS services in terms of managing the security and compliance on the customer's behalf. In the context of sovereignty, Control Towers offers a number of different capabilities for customers to do that. One is preventative control, and then the other is detective control. And then the third that we've recently launched is called proactive control. So let me dig deeper into it. So preventative controls are basically based on the service control policies, or what we call the SCPs. And it really maintains the compliance of your accounts by denying actions, API actions that could potentially lead to policy violations that customers would define. On the detective side, so this would be really useful when you have an existing account, existing workloads, and you want to identify what are the non-compliant resources and configurations that exist in your environment. And these are based on Security Hub as well as AWS Config. And then we have the proactive controls. So this is something new. More and more our customers are using infrastructure as code. And what proactive controls allows customers to do is basically identify non-compliance at that level, even before those requests hit the APIs. So last year, we launched 4 preventative controls for data residency and 13 detective controls as well. So from a preventative controls perspective, what this really allows you to do from a sovereignty standpoint is provision resources. Like you can completely block the ability for anyone to provision resources in unwanted AWS region. And all of this is managed by AWS Control Tower for the customer. So a customer, for example, in Europe can say, hey, I want my home region to be Frankfurt, and they can set up region deny list. So to block the ability for any resources to be created in any region other than Frankfurt, for example. So, and the one thing that really makes AWS Control Tower useful is it also provides a single pane of glass, right? So within the single console and portal, customer can see, hey, here are all my accounts, all my organizations. What detective guardrails have I set? What preventative guardrails have I set? What are all the non-compliance that the service detected? And then customers will be able to look at this and immediately take action to remediate some of this non-compliance. So far, when we talk about data residency control, we've been talking about customer data that customers have uploaded or generated on the cloud on AWS. But there are also some operational data that customers want more control on. So these would be like metadata. And as part of the AWS Digital Sovereignty pledge that we've made earlier this week, we'll continue to expand our data residency controls. We'll tackle operational data. And in particular, we're going to provide more control for customers to set guardrails around their identity and billing information as well. So now I'm going to pass it on to David, who's going to talk a little bit about how AWS is designed to remove any operator access.
Thank you. So yeah, for the last few years, I'm actually a Linux kernel hacker by trade, and I've been working on the Nitro hypervisor. So I've lived through some of this as we transitioned from the Zen system to Nitro, and we're going to go into a little more detail about Nitro in a minute. But more recently, as I said, we've been transitioning from doing this stuff quietly internally to actually talking about it and being able to show that evidence of this is how it works, such that people have a reason to trust us. And so earlier this week, and also at Reinforce in July, Cole McCarthy was presenting our externalization of these principles, the zero privilege operation framework. And it's like a tiering, and it starts with, basic data hygiene, best practices of knowing what data is important, what data customers care about, and knowing that this is here and treating it carefully. It goes on to the always-on accountability. It's basically secure logging, right? So whatever happens, there is an irrevocable record of that such that we can see. And so if we claim that certain things have not happened, access has not happened, there is a log which can demonstrate and prove that. And that's the next stage of the zero privilege operations ladder. And it moves on from there to contingent authorization. It's basically the four eyes rule. Any individual engineer doesn't have the agency to access certain things, to make changes without having permission granted by a second engineer or a third party. And we're looking at ways that we might extend that to have the contingent authorization be an individual in the country concerned, for example. And we're still working out how that might work. But then we move on to that final level. It's actually level 5 if you refer to the full presentations about zero privilege operations. It's the hermetic systems where these data adjacent accesses just aren't possible. And that's like the Nitro system we're about to talk about. It basically functions as an appliance. There is no API that lets me extract customer data from a Nitro system. The Zen system used to have a shell. I could log in and do things within the Zen control domain, the DOM0. That isn't possible in Nitro. There is no shell, no command prompt. It's only the APIs which are predefined and reviewed and cannot extract customer data. And that's taking us, as I said before, from we will not do that to we cannot do that. And that's why, it's about agency. We do not have the ability to make a decision that we are going to access this data. And that's the really important thing about digital sovereignty. So the Zero Privilege Operations Framework, we're externalizing this and giving materials to help customers implement these best practices while we're simultaneously driving these best practices internally as we have been doing for years. So the Nitro system, AWS Lambda, KMS, and the way that key management, ACM, is handled within Nitro Enclaves. All of these are sort of the poster children for how we do zero privilege operations and do this, follow these best practices to the letter. Sorry, do you want a second more to take a photograph of that? So Nitro. On the left-hand side here, you see the classic setup. And this is Zen as we had it in our older virtualization system. And everything runs on the host, an Intel host in those days. And you have the hypervisor and all the orchestration. And when a virtual machine wants to perform network or block access, what it will do is make a call, and it essentially traps out into the hypervisor, which is running on other CPUs in the same box, which will then perform the actual hardware disk or network access and service the requests for the virtual machine, and then the virtual machine will resume running. So as we transitioned to the AWS Nitro system, there were two key design principles, one of which was any CPU cycles running on the host in our software, in our hypervisor, and orchestration, those are cycles stolen from the guest. We want to get to as close to bare metal performance as possible in Nitro instances. The other key principle was the security model, that we actually want that full separation. So the orchestration and the implementation of storage and networking is physically separate on the Nitro card, the other side of a PCI bus, from the CPUs on which the customer workloads, the customer instances are running. So the storage is presented as a PCI device, an NVMe device. The networking is presented as a PCI device. So it is as if when you attach a new disk to your instance, it is as if a new PCI device has been hot plugged into that host, and then it's just PCI device assignment, so the virtual machine in question gets to see that device. And the customer code running on the host is completely isolated from any of the orchestration. It does allow us to give bare metal instances as well, because all we do is we drop that minimal Nitro hypervisor, and we allow the customer to have complete access to the hardware, modulo the Nitro security chip, which I'll talk about in a moment, because we wouldn't really like you to be able to flash the BIOS or do things like that when you have complete access to the hardware. And so you really do see hot-plugged devices as you add and remove disk and network from your bare metal machine. It's just like magic. So the three components, there's the Nitro card I talked about, which presents the storage and networking and performs the orchestration. There is no actual networking from the Nitro hypervisor running on the host side. It's very minimal. It communicates, it is told what to do, where to launch an instance by the Nitro card, communicating over the PCI bus. Then there's a Nitro security chip I mentioned, which performs certain protection when we allow a customer bare metal, but it also does a lot of the verification of software. So it checks the signatures on the Nitro hypervisor and the software running on the Nitro card before allowing a host to go into production. And then there's the Nitro hypervisor, our KVM-based minimal hypervisor, which runs on the host itself. So that is the small amount of our code that does run on the host side, on the Intel, on the Graviton, or the AMD chips, which does the bare minimum of hypervisor work to allow that pass-through of PCI devices. And even a bunch of the legacy Intel PC hardware, because we still have to go back to 1982 and support the chips that Intel chose to put on the boards in those days. And those still have to be emulated faithfully for legacy operating systems, or at least the bootloader to be able to use them. And though even many of those are emulated on the Nitro card rather than within the Nitro hypervisor, as a traditional hypervisor might have done. So that gives us that full isolation. It gives us the full security design such that this is an appliance. We just cannot subvert it. It's not within our gift to do that thing. So as I said before, we're starting to be a lot more open about this so that we can give this evidence, so that we can help people understand that this is the way it is. It's not just, yes, we get it right, you need to trust us. So here, published in the last week, we have this very deep dive into the security overview of the Nitro system. It's well worth a read if you're interested in that.
And one thing I'll call out is that this white paper, it's sort of rare and unprecedented from an AWS standpoint, right? We rarely go into sharing details of how our underlying architectures are designed. But as David mentioned, with the growing digital sovereignty requirements, even though we've been doing a lot of these things day one, we just have not been calling that, and what we needed to do, we realized, is we needed to come out and talk about it more, share it more in the detail with our customers, with our regulators, so that they can understand how AWS is designed and architected to help support those sovereign needs. This paper actually goes into quite a level of detail, so if you're interested, I do suggest that you take a read during your weekends.
So let's talk about Control Tower, which is one of the ways that we help customers to do the right thing, right? So Nitro is us doing the right thing, but it's no use for us to do the right thing if then customers and partners find it hard to use and find it hard to keep the system secure, find it hard to keep the data resident in the right place. So Control Tower is one of those things, and you know what they say about an API, it's not good enough for it to be easy to use correctly, it's got to be hard to use it wrong. Right? And that's what we attempted to do with Control Tower. Nitro Enclaves is another one of those things which is helping the customer. So Nitro Enclaves is a way for customers to protect certain parts of their workload against themselves. It allows you to set aside a portion of your, what we call the parent instance, some CPU cores and some memory, to run a tightly controlled enclave which doesn't have its own networking and disk. It communicates with the parent over a VSOC interface. And the parent cannot attack. It's almost like a virtual machine running within the parent, except that the parent doesn't own it. The parent cannot attack it, cannot see its memory. Very, very carefully controlled. And that allows us to do things like sort of software security modules. So working with ACM, so it can provision a private key for an SSL key, for example, if you're doing SSL termination on the host or if you're doing some other encryption. And like a hardware security module, the enclave can then produce a session key for you, but you, the parent instance, never actually has access to the private key. And all the plethora of software running in that parent instance, all the software framework, none of those have any possibility of breaking out and accessing that private key stored on the parent instance's disk because it is within the enclave. So we're seeing a lot of customers using this to help further protect and secure their own workloads as part of their overall strategy. So I think I've talked past the slides. So this is another part of our pledge that we announced this week. We'll continue to build additional access restrictions and limit access to customer data unless actually requested, given the ability to do so by the customer or, in certain cases, a local partner. In terms of data sovereignty, sometimes the key is it must be an agency locally who gives that permission. So another keystone is encryption everywhere. And we always encrypt everything, basically, is the rule of thumb. Right? So if you have your EBS volume attached to an instance, that will be encrypted with its own key. And if that instance is terminated, we immediately throw away that key, and the data are gone. Right? It cannot be recovered. So if a customer says, oh, I accidentally terminated my instance, please can you help me get my data back? Yeah, sorry, we can't do that. And honestly, you don't want to live in a world where we could do that. Everything is secure as possible at all times through full security, at rest, in transit. And we have a number of features through AWS KMS and Cloud HSM that we're about to talk through in a moment. So cryptography, so on the networking, we have encrypted links between data centers. Nothing ever leaves a data center without being encrypted, except to the public internet, of course. And on all our 5th generation with an N and 6th generation onwards instances, VPC encryption as well. So any network traffic leaving the Nitro host will be encrypted in hardware at line rate by the Nitro card before it even travels across our internal networks. And then it would be re-encrypted again before leaving the building to go to another availability zone or data center. On top of that, we have sort of the transport layer for TLS. We have the load balancing and CloudFront, and all of those do their own encryption and S2N and other crypto libraries on the host at the application level, followed by encryption of objects using the crypto SDK. So there's a full range of encryption to ensure that data cannot be leaked, data cannot be snooped upon. There is no point in the network at which, oh, look, we can see all the customers' data. We design such that this is fundamentally impossible with multiple layers of encryption, multiple layers of security. So KMS, the key management system, this is a key part of hundreds of AWS services, right? And if you cannot access your keys, if you cannot get the key for a given disk volume when you're trying to launch an instance, well, that means the instance can't launch. That's kind of painful, right? So we have the highest level of resilience guarantees for this, and the latency, and also security. So this is one of the areas where we are at that top level of the zero privilege operations framework, and basically, the keys never exist in plain text outside a hardware security module. When the KMS hosts are provisioned, when there are keys present, there is absolutely no operator access. There are no software updates allowed. After it's rebooted and gone into a non-operational state, when there are no keys present, then you can update software, but even then only with multi-party approval. And this is one of the cases where we have already been providing that attestation, that evidence, the SOC controls to demonstrate and working on FIP certification, et cetera, such that we can actually demonstrate and we can refer to audits of the KMS system demonstrating the handling of the keys. So Cloud HSM, this is a customer product where you can run a hardware security module within your own instances, and it helps to lift workloads from on-prem, where customers have been using HSMs on their own premises, into Cloud HSM instances. And this allows you to do more things that you can do with KMS keys, with legacy ciphers and a little bit more crypto agility. But you can also use your Cloud HSM as the backend for your KMS keys. So the keys that you use in KMS with various AWS services, they can actually be stored in your own Cloud HSM. And we're moving on from just within your own Cloud HSM to actually an external key store. So you can have a communication back to your own premises, and the keys for your, the master keys for your KMS are actually stored on your own premises. Now, this gives you some responsibilities for availability and latency, right? Because this is still on the critical path for launching all of your instances. And you might want to think twice about whether you really want to take that responsibility and put the link back to your premises in that critical path. But it's an option that we have. It's something we've announced this week, and it's very important for some people because 100% that any attempt to obtain the key for a disk volume, for example, will have to come to your HSM, and you will have to grant that access every single time that the key is made available. So that's another thing that's been announced this week as part of our sovereignty work. So back to the pledge, we commit to continue to innovate and invest in additional controls for sovereignty and encryption so our customers can encrypt everything everywhere with encryption keys managed inside or outside the AWS Cloud. So I think I'm handing back to Lewis to talk about resilience.
Thanks, David. I mentioned earlier resilience is a key pillar for digital sovereignty. And given a lot of the recent events, this has become, increasingly a hot topic. Customers want to make sure that their workloads can sustain any kind of disruption, whether it is natural disaster, network disconnection, or geopolitical influences. And before we talk about sort of the AWS global infrastructure and the architecture around our region, AZ, data centers, I do wanted to mention that I think a lot of time we see there's a big misconception in digital sovereignty that the cloud poses a risk to resiliency. But in our experience, that cannot be farther away from the truth. And it is actually one of the key benefits of using AWS is that we deliver like the highest network availability of any cloud, and that is not by accident. AWS is architected since day one to serve workloads that require the highest level of resiliency. If you see on the screen, like each of our regions are architected with multiple availability zones. Each of these availability zones are fully isolated. Each of these availability zones also consists of multiple data centers. And each of these data centers contains multiple redundant power and networking. And this really allows customers to be able to design their application to take advantage of this kind of infrastructure to develop high resiliency applications and workloads. And this is just something that cannot be achieved anywhere else. AWS also provides a continuum set of hybrid cloud storage and compute capabilities that allows customers to meet their requirements both physically and technologically. Beyond the obvious latency benefits that this architecture comes with, there's also significant benefit from a digital sovereignty perspective. Right? It allows customers to really operate their workloads in the geographical jurisdiction where the regulation actually dictates, hey, you need to have your data, you need to have all your compute in a certain geographical locations. So AWS regions, local zones, outposts, our Snow family of products are those services that allows customers to really put all of their data and compute locally where their government mandates. And all of these things are offered with the same reliability, security, performance, and operational consistency of AWS. And customers can use the same set of APIs and toolings to manage these. Beyond the infrastructure side of things, from a services standpoint, we also build our services to be regional whenever possible. Without any global dependency, and that really allows us to increase the resiliency and autonomy of these services in case of large-scale events. So today we have over 180 AWS services that are like fully regionalized and completely autonomous. And what that really means is, so if a region goes down, right, or get disconnected from the AWS backbone, like these services in that region will continue to operate. They are designed to continue to operate without any disruption. There are a few services that are pretty much intentionally built to be global, as their primary role is to perform like data transfers across the globe. So examples of that would be like content delivery, DNS, and so on. But even in those cases, customers are still in full control. They can choose to opt out of those services if they really wanted to make sure that everything stays within their country. So as part of this, we, again, continue to commit to enhance our range of sovereignty and resiliency options and allow customers to sustain operations through various extreme scenarios.
It's worth jumping in here with the anecdote that Dave Brown, VP of EC2, loves to tell
that's a good one.
About the regionalization. So back in 2008, they were looking at launching the second region in Dublin, and they had settled on a design where they had a single control plane, and you'd just be able to launch in Washington or launch in Dublin through entirely the same control plane and set of interfaces, and that was how it was going to be done. But then there was an incident with S3, and it transpires that a single router in Washington had taken to occasionally flipping bits. And in doing so, it had managed to corrupt the communication of S3 between regions, and managed to take down the sort of the in-memory index, as I understand it, of the S3 objects, and customers were getting 404 not found errors for S3 objects. This is not a happy thing for customers to see. And as part of the post-mortem for this event, which was resolved by basically turning it off and on again and rebuilding the indices, but as part of the post-mortem, it was decided that, yeah, this design where we have single control plane and everything depends on that, everything's interconnected, we're not going to do it like that anymore. And so there was a change of design, and that's why we have this fully isolated regional architecture. And yes, we understand that some customers look at it and say, but why do I have to go to a completely different console in order to manage these things? And this is the reason. It's complete regional isolation so that if those cables are cut, it continues to work on its own. There is no shared fate. There is no an error in one region can take down the service worldwide. It's really important. And again, this is not a new thing that's coming in with the sovereignty requirements. This is how we've built stuff basically from day one.
And we've just not been calling it that.
Yeah, we haven't been talking about it. Again, we will be talking about this a lot more to help build the confidence that people need as part of the sovereignty requirements.
That's right. And the other thing is earning trust is really sort of like the foundation of our business. And customers trust AWS to handle their most sensitive data. This is not a one-time exercise, and trust needs to be continuously earned through transparency and assurance. One of the key ways to earn trust is through certification and attestations, and AWS has achieved more certifications and attestations than any cloud provider. In fact, we recently achieved the Cloud Infrastructure Service Provider of Europe Data Protection Code of Conduct. Very long name, but in short, it's called CISP code, where more than, I think, 100 services have achieved this code. And this is something that has been independently validated by the European Data Protection Board, as well as approved by the French Data Protection Authority. Another example is the Germany C5 cybersecurity standard for public sector workload, and that is also something that we've achieved recently. And this is an area that we're going to continue to engage with regulators and governments, right, both in Europe and globally, to further discuss, how these regulations impact sovereignty. So there's a full list of this in our website, in the AWS artifacts, which is our go-to central resource for compliance. And as part of providing more transparency, we also released this privacy feature of AWS page. This page really allows customers to go and really determine, hey, what services can I use to meet my compliance requirements, particularly around data transfer. Most AWS services that you'll see on this list, and it's basically it's a long list. This is just like a top, above the fold screenshot. Do not automatically transfer data at all between regions. There are a small number of services, around 11 to be exact, that does, and these are sort of like the content delivery services, the DNS, right, where the global nature really necessitates data transfer. But by providing this transparency, what customers can do is they can say, hey, I can choose, given my workload, to opt out and not use some of these services, or I can choose to use these services, but also be transparent about it with my end customers, right? Another way to earn trust is through contractual commitments. And maybe not many customers know this, but we've updated our AWS terms of service to actually include contractual agreements to challenge any government request for personal data that is uploaded in their accounts. We also know that because transparency matters very much to our customers, we started publishing the biannual information request report. So this report goes through like the type and the volume of requests that AWS receives. And if you read through it, what you'll realize is that it really demonstrates how like disclosure by AWS of customer data is like extremely, extremely rare. And in fact, since this report is published, no request resulted in disclosure of customer data located outside of the US to the US government. So it's really like a hypothetical thing. And this is an area where we won't stop here. We'll continue to commit and provide more transparency and flexibility to meet the evolving privacy and sovereignty laws around the world. The last part that I want to talk about is around partners. One thing that we hear consistently across the board from our customer is that navigating through all the privacy, security, and sovereignty regulation has become increasingly challenging. Customers struggle to understand all of this, how it fits together. And this can stem from ambiguity both in terms of local regulation and also just a fragmentation that customers see across the world. AWS has a partner network of more than 100,000 partners that specializes in various different competencies and industry verticals. And these local trusted partners are a critical part of our strategy. So they are there to help provide customers guidance, to help customers set up a lot of the data residency controls, configure encryption, and really guide them through the journey as they adopt the cloud and meet the digital sovereignty requirements. So a couple of the examples are things like, for example, authority to operate, or the ATO program that helps partners really meet the customer authorization need, whether that is architecting, configuring, deploying, or integrating the tools and controls. We also have the AWS Managed Security Provider program, and this really allows the partners to help the customers to really operationalize their entire security operations. There's the AWS Security Competency Partners who can help customers elevate their security in the cloud. And in Germany, we partner with T-System to provide what we call the data protection as a managed service in AWS. And we're doing that in more regions and countries as well. For example, in Sweden, there's the AWS ClearStart program that really is focused on helping the public sector customer in Sweden to meet these growing requirements as well. And as part of our pledge, again, we'll continue to double down on our local partners and help them navigate and address their digital sovereignty needs. So I wanted to take a moment really to summarize some of the things that we have covered today. Firstly, we see that digital sovereignty is real. It is growing and rapidly evolving, both in Europe and around the world. The four essential aspects that we talked about, one is data residency, operator access, resiliency and survivability, as well as independence. And we see that the current industry approach to sovereign requirements is really leading to fragmentation, complexity, cost, but also slowing down the pace of innovation. And customers are forced to compromise on these compliances. But as it turns out, AWS, we have been doing this from day one. Sovereignty is part of our DNA, and we'll continue to commit to delivering more capabilities. So I believe Sunday night, we published, Matt Garman, who is our SVP in AWS, published a blog post about the AWS Digital Sovereignty Pledge. If you have not read through it, it'll be a good read. But it basically talks about how we've been architecting our systems, building our infrastructure in a sovereign way from the beginning, and the areas that we're going to continue to invest in as part of this journey to help our customers navigate through digital sovereignty. We covered a lot of these at a high level, but I'm sharing some resources that go into a lot more depth around these topics that we covered today, whether it is Nitro, whether it's compliance, our contractual agreement, the guardrails that we provide. We have various different resources that centralizes all of these to help our customers better understand this evolving landscape as well. So with that, I'd like to thank you again today for attending our session on digital sovereignty. If you have any questions, David and my emails are there. We're happy to engage with you and discuss how we can help you also meet your sovereignty requirements. Thank you very much.